Class 12 Mathematics, NCERT, New Delhi and COHSEM, Manipur. Unit 3 Calculus. Topic Applications of Derivatives. Subtopic Maxima and Minima. First derivative test motivated geometrically and second derivative test given as a provable tool. Simple problems that illustrate basic principles and understanding of the subject as well as real life situations. Exercise 6.5. Maxima and minima. Absolute maximum value of a function. What is absolute maximum value of a function? Let us define. A function f defined over closed interval ab is said to have an absolute maximum value at x equal to c belongs to closed interval ab. If f of c is greater than or equal to f of x for all x belongs to closed interval ab, and f of c is the absolute maximum value. Ayekpa diagram asida cup y equal to f of x haibadugi graph ne cup asi. x value a da mag function value atai c da oiba function value b da oiba function value a dagina b faubagi cup asida atatpa amata laite masibuni koina continuous define haribasi masida lai a dagi b faubagi marakta laiba function value pumnamakta a amasum b yauna s value pumnamakta f of c sina kwaidagi value chawi masibu aikoina a dagina b bauki close interval c gi manungda function value kwaidagi chawba hairagadi f of c asibani masi amakaktamak laigani close interval amagi manungda. Absolute minimum value of a function. A function f of x defined over closed interval ab is said to have an absolute minimum value at x equal to d belongs to closed interval ab. If f of d is less than or equal to f of x for all x belongs to closed interval ab, and f of d is the absolute minimum value. A amasum b closed interval asida cup asib y equal to f of x have a function asi defined tawi habadi there is no break tatpam ta laitre masigi manung da lariba c amasum d hariba point a ne b ne c ne d ne makoi mari si atai point sing khudeng makta su function value pumna makta kwaidagi pikpa si d da na pa habadi f of d asina kwaidagi function value pa masibuni aikoina absolute minimum value haribasi close interval amagi manungda function amagi absolute minimum value di amakaktamak laigani madu graph asida di f of d da ore. Relative or locant maximum value of a function. Relative or locant equivalent word ni maximum value of a function. A function f of x defined over the closed interval ab is said to have a relative or locant maximum at x equal to c. If f of c is greater than f of c plus a for all positive and negative values of a sufficiently small, f of c na f of c plus a pumnamakta chawba mafam asida a saibasi yamna pikpa negative natraga positive value ni haibadi diagram asida a dagina b bauki close interval asida mahak ase continuous ore haibadi define tore aduga f of c asidana swagi jaga asidana f of c na f of c awang value asiga f of c plus a na negative oibagi function value siga f of c plus a na positive oibagi function value siga swagi matek asigi c ga yamna naknaba point singi function value pumnamakta f of c no wangi masi aikoina locant maximum value f of c asibuna locant maximum value kowe point asibuna locant maximum value piba adugumba point ne. Relative or locant minimum value. A function f defined over the closed interval ab is said to have a relative or locant minimum at x equal to d. F of d is less than f of d plus a for all positive and negative values of a sufficiently small. Ayekpa diagram asida yengsi f of d asida na jaga asigo na function value kwaidagi pi masi f of d asibu minimum local minimum value kawi mafam diagram asida a dagina b bauki closed interval asida local minimum value piba jaga se ani lei asidagi khoina khangle karigumba function amagi minimum value asidi interval amadagi hena lebi yai relative or local maximum value interval amadagi hena lebi yai theorem. Let f be a function defined on an open interval I. Suppose C belongs to I be any point. If C has a local maxima or a local minima at x equal to C, then either f dash C equal to 0 or f is not differentiable at C. F haibase open interval I defined over function amani haina lawrasi. I interval still about point C haiba amaga lawkhatlasi. Adugumba point aduda function asigi local mini maxima or local minima layraba, then f dash c de mafam aduda 0 oiba ama or f is not differentiable at c. F as c the not differentiable oiba ama anis manungda ama chungani haba. Critical point. A point C in the domain of a function f at which either f dash c equal to 0 or f is not differentiable is called a critical point. C haibasi f ki domain da laiba point amani f dash c na 0 oiraba natra f is not differentiable at c oiraba adu oirabadi c asiba koina kari kawi critical point kawi. Working rule for finding local maxima or local minima first order derivative test. Local maxima natraga local minima of a function puthoknanabagi working rule ni first order derivative test first order da koina explain tawgani theory si. Let f be a function defined on an open interval I. Let f be continuous at a critical point C in I. Then if f dash x changes sign from positive to negative, x increases through C. Haibadi f dash s ki sign as a positive to negative ta C power hengalak x hengalakpa khudingi x hengalakpa da C power hengalabadi if f dash x greater than 0 at every point sufficiently close to and to the left of C, f dash C ki value f dash s ki value si 0 dagi chauraba C ga yamna naknaba C ki left laiba point sing dagi. The n f dash of x less than 0 at every point sufficiently close to and to the right of C, C right orabadi. Then C is a point of local maxima. C has a point of local maxima ni. X ki value hengalakpa matamda f dash C ki sign asi positive tagi negative ta lakani. C power matamda as well as matamasi da C ki value su S ki value su hengalakadabani. F dash C sina positive orambadagi f dash C se negative oira aba C power matamda as well as x hengalakpa matamda adugumba point C asida local maxima laigani. As in this picture asidi yauribasini. Assume the f dash x changes sign from negative to positive, negative to positive to hongaba as x increases through C, x na C power hengalakpa matamda. That is if f dash x less than 0 at every point sufficiently close to and to the left of C. C have a point asiga yamna naknaba C digi pikpa value singa duda f dash of x ki value se always negative oiraba, and if f dash x greater than 0 at every point sufficiently close to and to the right of C. C digi chauba C ga naknaba point singa duda f dash of x ki value se always positive oiraba, then C is a point of local minima. C have a safe local minima ni ma jaga asigi point of function value quite because C the oigani have as in this picture C the uribasini. If f dash of x does not change sign as x increases through C, then C is neither a point of local maxima nor a point of local minima. In fact, such a point is called point of inflection. F dash s ki sign is change x na C power ga hengalakpa matamda hongdrabadi C asibo koina local maxima pu point sunate local minima gi point sunate asugumba point asibo point of inflection kawi. Number 5. Working rules for locant maxima and locant minima. Locant maxima amasung locant minima puthoknabagi working rules puthoksi. Find the derivative, find the first order derivative, that is f dash x, if y equal to f of x or dy by dx puthokani ahanbada. Anisubada equate first order derivative haibadi f dash x to 0 ga manahanba or dy by dx oiragana 0 ga manahalani, and solve it for x madu x solve tawrani oithokpa yaba value x ki value sing lawkhatlani. Number 3, find the second order derivative, that is f double dash of x or y oiragana d square y by dx square gi maha ki second order derivative puthokani. But for that, let x equal to c be one of the values obtained in step 2. Step 2 the phangkiba solution x ki oibe yaba value sing manungdagi c asi amani haina lawrasi. If f double dash of c less than 0, then fx has relative maximum at x equal to c. If f double dash of c is greater than 0, then f of x has relative minimum at x equal to c. Number 3, if f double dash of c equal to 0, then the test fails. Ahum subok test asidi koi thengnararoi. Maxima and minima of a function in an interval. Interval ama piramaga function amagi maxima minima putokpa. If f of x is defined in closed interval ab, then the function will have an absolute maximum value. Maximum of f of a, f of b, f of c, f of d, so on. Absolute minimum value, the minimum of f of a, f of b, f of c, f of d, so on, where c, d are roots of f dash x equal to 0. The yauriba c, d haibasing a c, d f dash x equal to 0 gi root sing aduni a amasung b na function aduna define to the interval adugi end point sing mayam pumnamaki maximum duna absolute minimum value kawe, mayam pumnamaki minimum duna absolute minimum kawe. Exercise 6.5. Find the maximum and minimum values if any of the following functions given by. Makhada piriba function sing asigi lairabadi maximum amasu minimum value puto o. For Roman number 1. F of x is this. We know for x belongs to R, any real number amagi twice x minus 1 whole square is always greater than or equal to 0. Real number amagi square si saurabada can take any positive real number piklabada 0 ni. Negative oiba sunya yadi. Nakan animakta 3 adding taurasi. Asumna left side asi f of x na sinokro, we get f of x is always greater than equal to 3. Sidagi di mahaki minimum value di. Thus minimum value of f is 3, but there is no maximum value of f. Function ji minimum value di 3 ni, aduga maximum value di laiti putokpa ngamde. Assume na Roman number 2. F of x is 9x square plus 12x plus 2. Masisu quadratic ni completing perfect square same si. X yawa tam anisi perfect square ki manung da sanghal asi hapok option tauraga. We get this. For x belongs to R thrice x plus 2 whole square is greater than equal to 0. Sima di ko hana su khangkre. Adana minus 2 na tam kuding to both side ki khaido asi left side asi f of x ni. F of x asi always greater than or equal to minus 2. This shows that minimum value of f is only minus 2, but there is no maximum value. Magi maximum boundary laiti. Assume na Roman number 3. Here f of x is minus 1 times of x minus 1 whole square plus 10, which can be written as 10 minus x minus 1 whole square. For all x belongs to R, x minus 1 whole square is greater than or equal to 0, which is true, and 10 minus of this the less than or equal to 10 or a. Left side is the f of x ni, f of x whose value is less than or equal to 10. From this we conclude that maximum value of f is 10. There is no minimum value of f. For Roman number 4, g of x is x cubed plus 1. We note that the values of gx increases, x increases. Gx ki value dx hengali bamakai hengali have si koi khangle. So gx has no maximum value, ma ki maximum value laite. Similarly, the value of gx decreases as x decreases. Gx ki value dipikani x na pi bamakai. So gx has no minimum value of g. Gx की minimum value लेते. Question number 2. Find the maximum and the minimum values if any of the following functions given by 1. Minimum value, maximum value पुतवाई बने. F of x is modulus of x plus 2 minus 1. For x belongs to R, modulus of x plus 2 is greater than equal to 0. Subtracting minus 1 from both sides, we get this. Left is f of x whose value is greater than minus 1. Therefore, minimum value of f is minus 1. There is no maximum value of f. Similarly, for 2, for x belongs to R, modulus of x plus 1 is greater than equal to 0. Minus 1 puri rabadi sign do inequality sign change tokrane, and adding plus 3 on both sides we get this. Left is gx which is less than or equal to 3. Therefore, maximum value of g is 3 only. For Roman number 3, x is sine of twice x plus 5. For x belongs to R, sine of twice x is lying between minus 1 and 1, including the two numbers. Adding 5 in its term, in its member, we get this, which implies 4 less than equal to, this is equal to I of x, and this is equal to 6. Therefore, I of x minimum value is 4, maximum value is 6. Therefore, minimum value of ice is 4 and maximum value of ice is 6. For Roman number 4, f of x is modulus of sine of 4x plus 3. We have sine of 4x is lying between minus 1 and 1, including the two numbers. For all x belongs to R. Adding plus 3 in its member, we get this. And simplifying, we get 2 less than or equal to sine of 4x plus 3, which is less than equal to 4 for all x belongs to R. Taking modulus in its member, we get this. From this, we conclude that maximum value is 4 and minimum value is 2. For Roman number 5, I of x is x plus 1. X belongs to open interval minus 1, 1. Clearly, I of x is increasing function in minus 1, 1. It is impossible to find out minimum value at the right of minus 1. Minus 1 ki oida minimum value putok privacy impossible ni. Similarly, its maximum value lies above about 1. Maki 1 ki manakta maximum value lay, but it is impossible madu putok ngamde. Hence, f has no minimum value and a maximum value. F have a function ki maximum value laite, minimum value laite. Question number 3. Find the locale maxima and locale minima if any of the following functions. Find also the locale maximum and locale minimum values as the case may be. Piramiba function ki locale maxima, locale minima putu locale maximum amasu locale minimum values singadusu putu. For Roman number 1, f of x is x square, whose derivative is twice x, and its second order derivative is 2 only. For maxima or minima, we have to put f dash x equal to 0, whose value is x, twice x equal to 0, gives x equal to 0. Also, f double dash of this 0 is always 2, which is greater than 0. Thus, f has a locale minimum value at x equal to 0, and its locale minimum value is given by f of 0, that is 0 square equal to 0. For Roman number 2, here g of x is x cubed minus thrice x. Its derivative, first order derivative is thrice x square minus 3, and second order derivative is 6x. For locale maxima or minima, put g dash x equal to 0, that is 3x square minus 3 equal to 0, we get x equal to plus minus 1. Now z double dash of 1, that is 6, 6 into 1 is 6, which is greater than 0, and z double dash of minus 1 is minus 6, less than 0. Thus, z has a locale minimum value at x equal to 1, and its value is z of 1 equal to 1 cube minus 3 into 1, that is minus 2. Also, Also z has a locant maximum value as x equal to -1, and its value is z of -1, that is -1 cube minus 3 into -1 equal to 3 minus 1, that is 2. For Roman number 3, is x is sin x plus cos x, x lying between 0 to pi by 2. Implies is dash x whose derivative is for sin x, it is cos x. For cos x, its derivative is minus sin x. Again, its the derivative with respect to x is this. For locant maxima or minima, we have to put is dash x equal to 0, whose value is cos x minus sin x equal to 0, implies tan x equal to 1, implies x is pi by 4. Now, is double dash of pi by 4 is a negative number less than 0. Thus, is of x has a locant maximum value at x equal to pi by 4, and its value is is of pi by 4, that is sine of pi by 4, that is 1 by root 2. And the cos of pi by 4, that is 1 by root 2, gives root 2. For Roman number 4, here f of x is sin x minus cos x, x lying between 0 to twice pi. Let us find out first order derivative and second order derivative respectively. For maxima or minima value, f dash x equal to 0 gives cos x plus sin x equal to 0 gives tan x equal to -1. Solving tan x equal to tan of 3 pi by 4 or tan of 7 pi by 4 gives x equal to 3 pi by 4, that is 135, and 7 pi by 4, 7 pi by 4, that is 225 degree. These two angles lying between 0 to 360. Now f double dash of 3 pi by 4 is minus, and f double dash of 7 pi by 4 is positive. Thus f of x has a locant maximum value at x equal to 3 pi by 4, and its value is f of 3 pi by 4 equal to sine of 3 pi by 4 is this, cos of 3 pi by 4 is 1 by root 2, we get root 2. And has a locant minimum value at x equal to 7 pi by 4, and its value is f of 7 pi by 4 equal to sine of 7 pi by 4 is minus 1 by root 2, and minus cos of 7 pi by 4 is minus 1 by root 2, that is minus root 2. For 5, Roman number 5, f of x is this, its first order derivative is this, and second order derivative is this. F dash x to 0, the putting away, we get this. From this we have solved x is 1 or 3. Now f double dash of 1 is negative and f double dash of 3 is positive. Thus f has a locant maximum at x equal to 1, and its value is f of 1. We have 19. Also f of x has a locant minimum value at x equal to 3, and its value is f of 3. We get 15. Roman number 6. For question number 3, Roman number 6, gx is this. Its first order derivative is this, and second order derivative is this. For extreme points, z dash x equal to 0, whose value is this, and solving x we get plus minus 2, but x should be 2, x equal to 2. Now z double dash of 2, whose value is positive. Thus x equal to 2 is a point of minima, and minimum value z of 2 is equal to 2 by 2 plus 2 by 2, that is 2. For Roman number 7, z of x is 1 by x square plus 2. Therefore its derivative is minus twice x by 2x square plus 2 whole square. And its second order derivative, applying quotient rule, we get this. Solving this. For maxima or minima, z dash x equal to 0 implies x equal to 0. Now z double dash of 0 gives a negative number, that is less than 0. Thus gx has a locant minima at x equal to 0, and locant minima value is z of 0, that is half. Question number 3, Roman number I, f of x is x root over 1 minus x. and first order derivative applying product rule, we get this. Again, second order derivative is, we get this. Simplifying, we get this. For critical points or for extreme values, f dash x equal to 0 gives, solving, we get this, x equal to 2 by 3. Now f double dash of 2 by 3, we get a negative number less than 0. Therefore, locant maxima point at x equal to 2 by 3 and locant maxima value is f of 2 by 3. That is x the 2 by 3 since the loss, see the 2 by 3 since the body, we get 2 root 3 by 9. Question number 4. Prove that the following functions do not have maxima or minima. Makhagi function sing asigi maxima minima leite habedu praman tau. Roman number 1. F of x is e to the power x is derivative, that is f dash x is e to the power x. Clearly f dash x does not equal to 0 for any value of x. So f of x equal to e to the power x does not have a maxima or a minima. For Roman number 2, gx is log x whose derivative is 1 by x. Clearly g dash x does not equal to 0 for any value of x belongs to domain of g. So gx equal to log x does not have a maximum or a minimum. For Roman number 3, ice of x is this, whose derivative is this. For extreme points ice dash x equal to 0, we get this quadratic equation in x. But this equation gives imaginary values of x, no real value of x. So ice dash x does not equal to 0 for any real value of x. Hence, ice of x does not have a maximum or minimum. Question number 5. Find the absolute maximum value and absolute minimum value of the following functions in the given intervals. Absolute minimum value, absolute maximum value put to U. For Roman number 1, f of x is, whose derivative is thrice x square. For critical points or for minimum, for extreme points, f dash x equal to 0 gives x equal to 0. Now f of 0 is 0 cube, whose value is 0. F of minus 2 is minus 2 cube, that is minus I. F of 2 cube is I. Thus absolute maximum value is maximum of these three values, that is I. And absolute minimum value is minimum of from these three values is minus I. For Roman number 2, f of x is sin x plus cos x. X belongs to closed interval 0 pi, whose first order derivative is for sin cos x, for cos x minus sin x. Now f dash x equal to 0 gives x equal to pi by 4. Now f pi by 4 whose value is root 2 and f of 0 whose value is 1. F of pi is also minus 1. Thus absolute maximum value is root 2 1 minus 1, from which the greatest one is root 2. And absolute minimum value is minus 1. For Roman number 3, f of x is this, whose derivative is 4 minus x. Now f dash x equal to 0 gives x equal to 4. Now f of 4 is 8, f of minus 2 is minus 10, f of 9 by 2 is 63 by 8. Therefore absolute minimum value is minus 10 and the absolute maximum value is 8. For Roman number 4, f of x is this, whose derivative is 2 times of x minus 1. Now f dash x equal to 0 gives x minus 1 equal to 0. This gives x equal to 1. Now f of minus 3 is 19. F of 1 is 3. F of thus absolute minimum value is 3. and absolute maximum value is 19. Question number 6. Find the maximum profit that a company can make if the profit function is given by p of x equal to 41 minus 42x minus 18x square. Maximum profit put to U heavenly. Here px is this whose derivative and first order derivative is this, second order derivative is minus 36. For critical points or extreme values, p dash x equal to 0 gives x equal to minus 2. Now p double dash of minus 2 is minus 36 less than 0. Thus maximum profit is at x equal to minus 2, and maximum profit is p of minus 2, whose value after solving we get 113 units. For question number 7, find both the maximum value and the minimum value of this function on the interval closed interval 0, 3. F of x is this, whose first order derivative is this. Factorizing, we get this. For critical points or for extreme values, we have to put f dash x equal to 0 and solving x equal to 2 only. Now f of 0 is 25, f of 2 is minus 39, f of 3 is 16. Therefore minimum value is minus 39 and the maximum value is 25. For question number 8, at what points in the interval 0 to twice pi does the function sin twice x attain its maximum value? Here f of x is sine of twice x on 0 to twice pi, close interval. F dash x is this, f double dash of x is equal to this. For critical points, f dash x equal to 0 gives cos of twice x equal to 0, gives twice x equal to twice n plus 1 odd number times of pi by 2, where n is an integer. Solving x, we get x when n is 0, x is pi by 4. When n is 1, x is 3 pi by 4. When n is 2, x is 5 pi by 4. When n is 3, x is 7 pi by 4. When therefore x can take pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. Now f of 0 is 0, f of twice pi is 0, and f of pi by 4 is 1, f of 3 pi by 4 is minus 1, f of 5 pi by 4 is 1, f of 7 pi by 4 is minus 1. Thus f attains maximum value at x equal to pi by 4, pi by 4, pi by 4, and at x equal to 5 pi by 4. Question number 9. What is the maximum value of the function sin x plus cos x? Let f of x equal to sin x plus cos x, whose derivative, first order derivative and second order derivative are this and this. For critical points, f dash x equal to 0 gives cos x minus sin x equal to 0. Solving 10x equal to 1 gives x equal to pi by 4. At x equal to pi by 4, f double dash of pi by 4 is a negative number. Therefore x equal to pi by 4 is a point of maxima, and the maximum value is f of pi by 4, that is sin pi by 4 plus cos pi by 4, that is 1 by root 2 plus 1 by root 2, that is root 2. For question number 10, find the maximum value of this function in the interval days. Find the maximum value of the same function in the closed interval minus 1 minus 3 minus 1. Here f of x is this, and whose first order f dash x is this. For critical points, f dash x equal to 0 give x equal to minus 2, but x therefore x is 2, because x equal to minus 2 does not contain in the closed interval 1, 3. Now f of 1 is 85, f of 2 is 75, f of 3 is 89. Maximum value is thus maximum value is 89 at x equal to 3. For second part, x belongs to this. then x belongs to minus 3 minus 1 gi close interval yaubu oirabadi asai gi hundokiba s ki value minus 2 du oirani. Now f of minus 3 is 125, f of minus 2 is 139, f of minus 1 is 129. Our value ahum sigi manungdagi maximum value d. Thus maximum value is 139 at x equal to minus 2.